In this video, I want to talk about transfer functions. And what I want to do is I want to take an example or two and try to get the transfer functions of systems. Now, the reason why transfer functions are important is because if we have the transfer function of a system, we have the input output characteristic of that system. And once we have that input output characteristic, we basically know how the system would behave for any kind of input. So we're looking at transfer functions. Let's start with our first example. So let's say we have a simple RC circuit here, and our input V1 is applied to this RC circuit, and the output is read across this capacitor C. So how are we going to get the transfer function of this system? First of all, what would the transfer function of this system look like? Now, what is the output variable in this system? The output variable is V2t. So it's basically in the Laplace transform, the output variable is V2s. That divided by the Laplace transform of the input, which will be V1s. So that is going to be our transfer function. So if I write my transfer function as Ts, so that is going to be our transfer function. So this is what we are trying to find out, right? Okay. What do we know about this system? What we know is what is the input output relationship of a capacitor. So we know that in a capacitor, I is equal to C dV over dt, right? And if we transform this into the Laplace domain, we get, instead of I as a time function of time, we get I as a function of the Laplace variable S equal to C dV over dt. A differential is represented as S in the Laplace domain, and we get Vs. So we could write this as, let's say, Vs equal to Is over S times C. So this is the opposite relationship, voltage in terms of the current. Oh, I'm sorry. C comes in the denominator, right? Okay. So having this, so basically what we are saying then, okay, let's just then think about what the impedance of this capacitor is. So Zs is equal to Vs over Is, which is equal to 1 over Cs. So the voltage over current, which is the impedance of the capacitor, is basically 1 over Cs. So then, if that is the case, what is V2 going to be in terms of V1? So there are various ways to do this. One of the ways is to find out what is the total impedance looking into the circuit from here. And that is going to be basically the impedance of this resistor plus the impedance of this capacitor, right? So it's going to be R plus 1 over Cs. And that the voltage V1 over S divided by the impedance is going to give us the current Is. Now we also can see that V2 over V2S is equal to Is times 1 over Cs, right? Because this voltage V2 is the voltage across this capacitor, and the impedance of the capacitor is 1 over Cs times the current gives you the voltage. Now let's replace this Is from here. So what do we get? What we get is 1 over Cs divided by R plus 1 over Cs V1S. And from here, you can see that the transfer function, which is equal to V2S over V1S, becomes equal to 1 over Cs over R plus 1 over CS. Okay, so what have we done? What we have done is we have found out the the transfer function of this particular circuit. We did that by finding out what the relationship of V2 is in terms of V1. So we've got V2 over V1 in the Laplace domain, and we see that it is given by this equation here. And that kind of defines the input output characteristic of our system. Okay, so let's take one more example and see how that works. I'm sure you are quite familiar with the circuit on this slide. It's basically a inverting amplifier, right? So what is the relationship? What is the transfer function of this system? Okay, we could go through all the circuit equations, but I think in this case we don't need to, because we already know that V output over V input, and this is with respect to time, is equal to minus R2 over R1, right? And so basically, if you convert this into the Laplace domain and write the transfer function and want to say V naught S over V in S, so you're converting into the Laplace domain, it's just going to just stay the same, and you have minus R2 over R1. Okay, so the output is going to be this constant times the input. So this process of finding out transfer functions of systems is very important because it gives us the input output characteristic, and that using these transfer functions, then putting different systems together, you can build a much more complicated system, and we'll take a look at that in the next few videos.